China's humanoid robots are now running faster than ever before. But have you ever wondered what the world would look like if the greatest race on Earth was no longer between humans? Imagine sitting in front of your television one day, waiting for the Olympic 100-meter final to begin. The stadium is packed. Millions are watching around the world. But when the cameras zoom into the starting line, there isn't a single human athlete. Standing there instead are humanoid robots, built to run faster, react quicker, and never grow tired. It sounds impossible. Yet with every passing year, that future feels a little less like science fiction. So how did China go from chasing the world's robotics leaders to building some of the fastest humanoid robots ever created? And is this really just about speed? Or is there something much bigger happening behind the scenes? So what really happened? Today, come along with us as we retrace China's journey one step at a time to discover how a country that was once seen as playing catch-up is now forcing the rest of the world to rethink the future of humanoid robotics. And who knows? By the end of this story, the thing that stays with you the most might not be how fast these robots can run, but what their existence says about the future we're all heading toward. The world didn't expect China. For decades, the future of humanoid robots seemed already decided. If anyone was going to build the machines that could walk, climb stairs, and hold something close to a conversation, most people assumed it would be the United States, with its Silicon Valley labs, or Japan, with its lifelong obsession with human-like machines. China rarely entered that conversation at all. To much of the world, it was simply the factory floor of the planet, a country that assembled other people's inventions, not one that dreamed up the next. But while the camera stayed fixed on flashy stage demos overseas, something quieter was unfolding inside labs most people had never heard of. Chinese engineers weren't asking how to make a robot look impressive for 30 seconds under studio lights. They were asking a harder question. How do you build a machine that survives outside the lab? A polished showroom floor forgives almost anything. Gravel doesn't. A sudden shove doesn't. Carrying real weight across an uneven factory floor without toppling over doesn't. That single shift in the question rewired the entire race. A genuinely useful humanoid was never one breakthrough. It was 5 happening at once. Stronger motors, lighter batteries, faster processors, sharper sensors, smarter software, each one pushing the others forward. None of those upgrades made headlines on its own, but together they were quietly rebuilding an entire industry from underneath. And almost nobody outside the country noticed that it wasn't just producing better prototypes, it was building the whole ecosystem beneath them. Universities were training a new generation of engineers. Startups were competing head-to-head in the same handful of cities, and that competition did something no single company could ever do alone. It forced every new robot to outrun the last one just to survive. For a long stretch, none of it produced a single headline moment. The world kept watching elsewhere. Then, almost without warning, a machine stepped onto an athletics track, and instead of taking one careful step after another, it broke into a sprint. That clip alone didn't explain anything. It just raised the question everyone suddenly wanted answered. How does a country nobody was watching close a gap like that? The honest answer isn't flattering to the people who missed it. Nobody had been hiding anything. The signs were all sitting in plain sight: patent filings, university enrollment numbers, factory output reports, the kind of data nobody outside an industry ever bothers reading until it's too late to act on it. The world wasn't blindsided by a secret. It was blindsided by its own habit of looking somewhere else. And the answer to how it all actually happened starts with one very unlikely person, an engineer who almost didn't make it into graduate school in the first place. The breakthrough. Unitree H1. Long before any of this, Wang Xingxing was just a kid in Ningbo who liked taking things apart to see how they worked. He wasn't a prodigy on paper. His English was weak enough that it nearly cost him a place in graduate school. Nothing about him looked like the future founder of a company that would one day outrun Boston Dynamics. At university, chasing his master's degree, he built something almost out of stubbornness. Every serious-legged robot at the time, Boston Dynamics included, ran on expensive hydraulic systems. Wang built his instead from cheap, off-the-shelf motors, the same kind used in drones. He called it X-Dog. People who knew the field said it shouldn't have worked at that price. It won a national competition anyway, and the footage of it walking spread through Chinese tech circles before he'd even finished defending his thesis. That was the moment everything tilted. Investors started calling. He'd already taken a job at a drone company. He didn't stay long. With a modest slice of angel funding, barely enough to rent a small office in Hangzhou, he started a company and gave it a name that stuck: Unitree. Years of unglamorous work followed robot dogs, mostly, quietly capturing a majority of the world's market for four-legged machines, while almost nobody outside the industry paid attention. Then Unitree revealed something different, a full-size humanoid called H1. Most people watching expected another careful, cable-assisted demo, the kind the industry had already seen a dozen times over. H1 didn't tiptoe. It ran, under its own power, balancing on nothing but its own motors and sensors. Here's why that mattered more than it sounds. Walking lets a robot keep one foot on the ground almost constantly, a safety net it can lean on. Running throws that net away entirely. For a fraction of every stride, both feet leave the ground at once, and the robot has zero physical support. It has to calculate exactly where it will land, how much force each joint needs to produce, and how its whole body should react before its foot has even touched down. Get that math wrong, even slightly, and a robot doesn't stumble gracefully. It falls hard. That's precisely why some of the most advanced humanoids in the world could walk beautifully for years and still couldn't run at any real speed. H1 solved it with actuators built to be powerful without being heavy, and a control system recalculating the robot's posture hundreds of times every second fast enough that by the time a human eye registers a stumble, the machine has already corrected for it several times over. It posted a running speed fast enough to set a world record, edging past Atlas, the Boston Dynamics machine that had quietly defined the ceiling of the entire industry for years. Wang wasn't finished making promises either. He told a public audience that Chinese humanoid robots would soon outrun Usain Bolt. Not long after, H1 hit a peak speed that came within reach of Bolt's own average pace across his world record for a few staggering seconds. A machine built in a rented office was keeping stride with the fastest human who ever lived. Zoom out for a second. This is a man who almost didn't get into graduate school over a language exam. Not so long ago, he was building robot dogs with a handful of employees in a small city office. Now picture him seated at a recent industrial summit, next to the founders of Huawei and BYD, not as a guest, but as a peer. Here's a question worth sitting with before we go any further. Was H1 the moment China actually became a serious player in robotics, or just the first time the rest of the world happened to look up? We'd genuinely like to know where you land on that, so take 10 seconds and drop your take in the comments. Some of the best stories in this series have started from arguments that began right there, and we actually read every single one. And if this kind of deep dive into how things really get built is your thing, this is a good moment to hit follow. There's a lot more of this story still ahead, and you won't want to walk in halfway. Because H1, as fast as it was never the finish line. It was the first visible signal of something much bigger, and the robots built after it wouldn't just have to run. They'd have to prove they could keep going, carry real weight, and survive ground that never forgives a mistake, faster than speed. Unlike H1, the next machine to matter wasn't built to grab headlines with a single sprint. Its job was to answer a quieter, more practical question. Can a humanoid sustain high-speed movement for long stretches without overheating, losing efficiency, or shaking itself apart? The company chasing that answer was RobotEra, and the robot it built was called Star1. When RobotEra unveiled it, most coverage fixated on one number, a fresh speed record, edging past H1's own mark. But chasing a faster stopwatch was never really the point. The company wanted proof that speed could survive outside a lab, so it sent Star1 out onto rock, grassland, gravel, and open desert road, far from anywhere with a flat, forgiving floor. In one test, two identical units raced each other across that terrain. One ran barefoot, the other wore a pair of sneakers and started behind. It closed the gap anyway, and held the lead for more than half an hour straight. It sounds almost absurd that footwear decided the outcome. That's exactly the point. Real ground isn't a laboratory floor, and RobotEra wanted a robot that could survive it, not just outrun a rival under studio lights. The next version kept the same platform but changed the question entirely, not how long could it run, but how intelligently. Engineers added stereo cameras and full 3D perception, so the robot could map the ground ahead and plan its footing before it ever reached an obstacle, instead of reacting after the fact. The same robot that could sprint at full tilt could now sort objects, use tools, and carry loads with real precision. It had stopped being an athlete. It had started becoming a worker. While RobotEra chased endurance and perception, a different team in Shenzhen made a completely different bet. LimX Dynamics decided that carrying a crate mattered more than winning a race. The instant a humanoid lifts extra weight, its entire center of gravity shifts, and every step becomes harder to control. So instead of chasing a higher top speed, LimX built joints that could change their own stiffness on the fly, letting its robots redistribute weight while walking, turning, and hauling real loads without breaking stride. It wasn't the fastest humanoid coming out of China. It was one of the most useful. And in another corner of the same industry, a company solved a problem that had nothing to do with speed, strength, or intelligence at all. How do you actually build these things by the thousand? One factory floor was built to do exactly that, turning out a finished humanoid roughly every half hour, dozens of assembly stages and inspection points deep, at a pace no other humanoid production line on Earth could match. It wasn't a demo built for investors. Real manufacturers were already placing real orders. By now, a pattern had become impossible to miss. Different companies chasing entirely different problems, speed, endurance, stability, scale, all converging on the same destination from different directions. China's humanoid industry wasn't advancing one breakthrough at a time. It was advancing on every front simultaneously, each company quietly standing on ground the others had already cleared, which raises an uncomfortable question. If 5 separate companies keep solving 5 separate problems this fast, without any of them appearing to coordinate, what, exactly, is holding this whole thing together? The answer isn't as complicated as it sounds. And once you see it, you won't be able to look at a single one of these machines the same way again. The secret behind the rise. By now, one thing should be impossible to ignore. China wasn't building one impressive humanoid. It was building dozens from a handful of companies at the same time. And at first glance, they look like a loose collection of unrelated success stories, each one solving its own separate problem. They aren't unrelated at all. Behind every one of those robots stands the same thing, an entire ecosystem, and that ecosystem might be the real invention in this whole story. Look underneath any humanoid shell, and you'll find thousands of parts that never make it into the demo footage. High-torque motors, precision reducers, AI processors, cameras, battery packs engineered to survive constant vibration and heat. Every one of those components has to work together flawlessly. If a single part falls behind, the whole robot falls behind with it. For years, that was the real wall in this industry. Building a humanoid was never just a software problem, it was an industrial supply chain problem, and China had quietly been solving it long before anyone called it a robotics strategy. The country had already become the world's largest maker of lithium batteries, electric motors, and cameras, almost none of it originally built for robots at all. It was built for phones, drones, and electric cars. By the time the humanoid race accelerated, all of that infrastructure was simply sitting there, waiting to be repurposed. One recent industry analysis put a hard number on just how much that head start is worth. Strip a leading American humanoid of every Chinese-made component, and its hardware cost doesn't rise a little. It nearly triples. Now hold that number next to the price tag Unitree puts on its own consumer humanoid, a fraction of the cost, built almost entirely from parts the country already made for something else. Hardware was only the first advantage. The second was intelligence, because a robot with perfect motors and no brain is still just an expensive machine. And understanding a room, rather than simply moving through it, can't be hand-coded. It has to be learned, one clumsy step, one dropped object, one recovered stumble at a time, across thousands of machines feeding lessons back into the same shared systems. One project made that philosophy explicit instead of accidental. A state-backed lab built its own humanoid, proved it could run purely on electric power with no hydraulics at all, and then did something almost no company in this race has ever chosen to do. It gave the robot away. Structural drawings, software, control systems, open to any university or startup willing to build on top of it, instead of guarding it as a trade secret. Within about a year, well over 100 machines built on that shared foundation were already patrolling power plants and sorting warehouse shelves. None of these advantages exist on their own. The capital, the components, the intelligence, the data, the open platforms, each one makes the next one cheaper and faster to build. That compounding effect, more than any single robot sprinting down a track, is the real secret behind China's rise. So here's a genuine question for you. Between everything we've covered, better hardware or smarter AI, which one do you think actually decides who wins this race? We're curious enough that we might build a whole future episode around whichever answer shows up the most in the comments, so don't hold back. Because even with world-class components, sharp AI, and one of the strongest manufacturing ecosystems on the planet, China still has one problem left to solve. Building a remarkable robot is one thing. Convincing the real world to hand it a real job is something else entirely, and that's a very different kind of hard. Why this changes everything. For years, humanoid robots were judged by one simple question. What can they do? Can they run? Can they climb stairs? Can they carry something heavy without falling over? That question no longer captures what's actually at stake, because the real one is much bigger. What happens once millions of these machines become cheap enough for ordinary businesses to actually deploy? That's the future being quietly built toward. Manufacturing has been this economy's backbone for decades, and yet even with an enormous workforce, factories are running into a problem that has nothing to do with robotics at all. Populations are aging, labor costs keep climbing, and many of the most physically demanding jobs are getting harder to fill every year. These aren't problems unique to one country. They're challenges facing economies everywhere, and humanoid robots are increasingly treated as one of the only realistic answers on the table. Unlike the industrial arms bolted behind safety cages, a humanoid is built to move through spaces already designed for people walking factory floors, using tools shaped for human hands, carrying materials between stations without a single wall needing to be rebuilt. That single design choice quietly rewrites the economics of automation. Instead of tearing down a factory to make room for machines, companies can bring machines into factories that already exist. The same advances in perception and mobility that let a robot navigate a warehouse aisle could, in time, help it assist inside a hospital, inspect dangerous infrastructure, or support someone who can no longer safely live alone. None of that arrives overnight, and it's worth saying plainly, humanoid robots remain expensive, power-hungry, and mechanically complex. Plenty of tasks a 5-year-old handles without thinking are still genuinely hard for a machine, and real questions about safety, regulation, and the future of work remain wide open, with experts still arguing about how quickly any of this actually scales. But history has a habit of repeating a very specific pattern. Transformative technology almost always looks underwhelming right up until the moment it becomes impossible to avoid. The first personal computers looked like expensive toys. The first smartphones looked unnecessary. The earliest electric vehicles were dismissed as impractical golf carts. Each one eventually reshaped an entire industry, and humanoid robots may be standing at exactly that same turning point right now. Whether one country ends up dominating this race outright, or whether the rest of the world closes the gap in time, is still genuinely unknown. What's no longer in question is that the conversation itself has already shifted. It isn't about whether these machines become part of daily life anymore. It's about how soon they arrive, and how ready the rest of us will be when they do. And maybe that's the part of this story that should stay with you longest, not the speed record, not the specs, but the quiet realization that somewhere, right now, the answer to that question is already being decided. When people first saw a humanoid robot sprinting down a track, most assumed they were watching a single engineering breakthrough. But as this story has shown, speed was never really the point. Behind every record-breaking machine stood engineers solving 5 different problems at once, and years of relentless, largely invisible improvement, one breakthrough quietly enabling the next, until an entire ecosystem, not any single robot, became capable of reshaping the future. That's how the fastest humanoid robots on Earth got built, not through one extraordinary invention, but through countless smaller ones, layered on top of each other, until the picture became impossible to ignore. Whether the rest of the world catches up is still an open question. What's already certain is that the race has only just begun. Somewhere right now, another humanoid robot is taking its first steps. Another breakthrough is already underway, and another chapter of this story is quietly being written before the last one is even finished. Maybe that's the real lesson underneath all of it. Not that one country got there first, but that the ground is still moving under everyone's feet, including the companies that think they're already winning. The robot you just watched sprint down a track isn't the ending of this story. It's barely the opening scene. Genuinely, thank you for sticking with us through this one. Stories like this take a lot of digging to get right, and it means something that you spent this time with us instead of scrolling past. If it was worth those minutes, a like or a follow doesn't cost you anything, but it tells us to keep chasing stories like this instead of something easier. No pressure either way, we're just glad you were here for this one. We'll be here when the next chapter starts.